We're going to pick up here with section 8.6, solving exponential and logarithmic equations. And before we get started on this section, I want to go back just a short trip down memory lane to section 8.4, where you were first learning about logarithmic functions. And I want you to remember the part that I told you on page 488, that the part that needed to be in a green box. I want you to remember the inverse operations. Remember when we were saying that if g of x, so if we have some function g of x that's equal to log of some base b of x, and we have a function f of x that's the exponential function b of x, that these guys are inverses of each other, right? These are inverses of one another because if you remember, y, if I, instead of g of x, I use y equals log base b of x. What does this mean? It takes, if I take b and I remember the answer is of a logarithm is an exponent. This is the equivalent is this, right? Of these two things. These are equivalents. If I flip the b and the x around, then I really essentially have y equals b of x, which is the inverse. Okay, so that's why they're inverses. And so remember when we were talking about that if we made function compositions out of them, they undo each other, right? And so if we did something along the lines of g of f of x, right? My outside function is the log, and then I put the exponential function f of x into x here, and that becomes b of x. They undo each other, and I release x out of there. Because they undo each other, and of course the vice versa. That this applies as well. I just want you to remember this because this technique is going to come into play. So okay, so back to here. This is the exponential function, and I put the logarithm in here, and this undoes they do undo each other since they're inverses, and that you get x when I do that, because this is going to be a technique that you're going to be using to solve these logarithmic and exponential equations. Okay, so in section 8.6. All right, okay, so now go ahead and go to page 501, okay, and let's just read this top part together under goal 1. Now you're solving exponential equations. I think goal 2 will be solving logarithmic. It says, one way to solve exponential equations is to use the property that if two powers with the same base are equal, then their exponents must be equal. And of course, they're talking about positive bases, okay? So it says for base being positive, 0. And of course, we don't want it to equal 1 because that won't give us a exponential function. That's just a constant function. They're saying that if b of x equals b of y, this is technically called, I think, the one-to-one property, but the book doesn't call it that. But anyway, if you have the same bases, and whatever you have up here in the exponents, if these are the same bases, you can set the exponents equal to each other, so therefore x equals y. Now, the other part that is missing is if you have, and I want to add this, it'll come into play a little bit later here in this section, but this property, it's also a one-to-one property, but it's with logarithms. It's saying if you've got a logarithm base b of x, and it happens to be equal to a logarithm base b of y, guess what? X equals y. So you can just set them equal to each other. All right, so put this at the top of your notes when you're solving these equations, because this is where all this is going to come into play, as well as the properties that you just learned in section 8.5. Those are going to come into play in this section as well. So you got your whole toolbox together, and the whole purpose of this is so that you can solve these logarithmic equations. All right, now let me clear the page. Okay. All right, so let's pick up with example 1. All right, it says for to the 3x equals 8 to the x plus 1. All right, they want you to use that property that they just said, where b to the x, if it equals b to the y, that x equals y. Now, are these the same base? No, they're not the same base. But with a little finagling, they could be rewritten so that they are the same base, right? They're really, both of those could be written as base 2, right? Because 4 is the same thing as 2 squared. So I could write this as 2 squared, right, to the 3x. And this could be written as 2 cubed. 8 can be written as 2 cubed to the x plus 1, right? All right, so if that's the case, then we got to remember our exponent properties. Remember a to the m raised to the n power. What is that? A to the m times n. All right, so we're going to do the same thing here with these exponents. We've got to multiply the exponents. So this becomes 2 to the 6x equals, and then I'm taking 3 and I'm really literally, I got to distribute this across. So this becomes 2 to the 3x plus 3. Okay, now I can use this property here because now these guys are the same base. I can just set the exponents equal to each other, and then it's just a really easy algebra problem that you could have solved back when you were in Algebra 1. So subtract 3x minus 3x. Okay, 3x equals 3. Oh, that's so nice. X equals 1. What you want to do, though, before, for every one of these problems, because it will be possible in some of these techniques to introduce extraneous results, meaning your algebra is okay, but your result doesn't work back in the original equation. So go back and test this out. So go back and check it. Make sure it's not extraneous. So we said 4 to the 3x. We said x is 1. Does that equal 8 to the 1 plus 1? Well, 4 to the third power, what is that? 4 times 4, right? Times 4, which is 64. So this, and then 8, this is 1 plus 1, so 8 squared, so that becomes 64. So this right here then checks out. Okay, let's do example 2. All right, example 2. Now this one says the technique you're going to use here is that you can take a logarithm of each side. You're using that inverse property. Remember, a logarithm can be the inverse of a exponential function. All right, so we got 2 to the x equals 7. All right, so we're going to remember this thing. And of course, our base is 2. So remember, if we say log base 2 of 2 to the x, what is that going to equal? Okay, this is me putting two inverses together, and x comes out, right? So that's what I'm going to do. I'm going to take log base 2 of both sides. So log base 2 of 2 to the x is good, and I got to do the same thing. I'm still practicing the algebra golden rule. Still going to be base 2, and I'm going to take it of the number 7. All right, well, so what's going to happen here? Well, this becomes x. X equals log base 2 of 7. Now, if you want to use your calculator to figure this out, right now I just want you to use the change of base formula so that you're comfortable with doing that. Some of you have TI-84s. You can actually use the math function in there and put the base in and have it calculated. But for right now, I want you to just practice being able to do change of base. So we'll convert it over to the common log. So we'll say x is equal to log, okay, this is base 10 now, of 7 divided by the common log of, now the base here, of 2. So put that in your calculators and you should get, let's see, log of 7 divided by the log of 2. And I get 2.8, 2.807. And pay attention on some of these where they tell you how far they want you to round them. Okay, all right, I'll come back here in the next video and start with example 3.